What's up, guys? In this video, what I want to do is do a little review of graphing a quadratic when a is equal to 1 or -1, and we're going to be dealing with some transformations. Now, before we get started, let's just make sure that we know what exactly a quadratic is going to look like with no transformations. So in this case, we have y equals ax squared, right? Now, hopefully recognize here we're going to have a vertex here at 0, 0. And then to find the next point, we can go over 1, up 1. And when we find the next point over there, we can go over 2, up 4. So 1, 2, 3, 4. Now, I'm typically like to just stick to these the first point, because what you can do is always reflect that about your axis of symmetry, which in this case is that y equals 0, and therefore you're going to get the exact same points. So therefore you can make the graph to look something like this. Now, we're not going to be dealing with this graph, and I don't really want to focus on creating a table of values. Hopefully you recognize these values and you're like, okay, I'm good with there. What we're going to focus on is using our transformations. Specifically, y is equal to a times an x minus h quantity squared plus k. All right. And that is going to be where h comma k is going to be our vertex. So if we have an h and a k, what that's going to do is that's going to be now either the lowest point or the highest point of our vertex. Now, in this case, you can see my h and my k is 0 and 0. But either way, like these represent your vertex. Okay. So if we're going to have transformations or an h and a k, that's going to be shifting, moving the graph left, right, up, or down. So let's kind of get into a couple examples. So therefore you're like, all right, I feel like I can like graph this quadratic now knowing some transformations. So the first one is y is equal to an x squared plus 3. Okay, so the main thing I want you to understand here is the only thing I'm adding is I'm adding outside the function, which is x squared. So you can kind of say here that my vertex in this case, and that's going to be kind of the first thing I always like to do when you're trying to graph a quadratic using transformation, is identify the vertex. So my vertex in this case is going to be 0, 3. Now there's no other transformation that's going on. So if my vertex went from 0, 0 to now 0, 3, hopefully you recognize all what happened was the graph got shifted 3 units up. So I can just go from 0, 0 to 1, 2, 3, right? And again, we can go over 1, up 1, over 1, up 1. And therefore that's not our best, but there is our nice, lovely graph. So what about if we have now y is equal to ax plus 3? Quantity squared. Now, in this case, you might say, oh, well, h is equal to 3, so therefore the graph is being 3 units to the right. But you got to make sure you got to pay attention. This is x minus h. So what we want to do is we want to rewrite this equation in this form. So therefore we can properly identify what the h is to find our vertex. So by doing that, I'm going to get a y equals a x minus a -3, right? Now, why am I doing it that way? Well, what is x minus a -3? That's the same thing x plus 3, right? So hopefully you recognize here that my vertex now is going to be a -3, 0, right? My h is equal to a -3. So I'm not shifting the graph up or down. I'm actually shifting the graph 3 units to the left, not the right. A lot of students will think it's to the right because they see that +3. But hopefully you recognize if you can put it into the correct form, you see this graph is actually shifting 3 units to the left. And then I already know over 1, up 1, I can go in both directions because I'm not having any transformations. And we're not going to do any of those transformations inside of this video. So you don't need to worry about that. We're going to keep everything. No stretches or compressions are going to be going on. All right, so now let's go and have a little fun here. What about if we add like a couple of transformations? So what if I had like y is equal to a 1 minus an x squared? Now, first thing I want you to recognize on this, that's not in this format, right? So what are we doing when we have a number like this? Well, what we're going to want to do in this case is we're actually going to want to rewrite this into our vertex form. So what I'm going to do is actually put the 1 on the up past the x squared. Notice this 1 is positive, so therefore that's going to be an x squared plus 1, okay? Now, again, let's identify the vertex. This is why identifying the vertex is so important. So if I identify this vertex, right, the vertex is going to be 0, 1. And the reason why that is so important is because a lot of students, when they see like multiple transformations, they don't know what to do first, right? They're like, should the graph, should I reflect it and then move it up? Should I move it up and then reflect it? We know the vertex is 0, 1, right? And now hopefully you recognize when you multiply by negative, when your a is negative, now the graph is going to be shifting down. It's going to be, not shifting down. It's going to be opening down. It's going to be reflecting down. Okay. So if I know the vertex though is at 0, 1, that's extremely important because now all what's happening is this graph is being shifted up 1 unit, right? Let's put it like right there, but now it's opening down. So left 1, down 1, and to the right 1, down 1. Okay. So the graph is going to look something like that. So it actually wasn't that bad as what we originally were thinking. What about if I have a problem like this? And let's do a horizontal as well as a, let's do a horizontal as well as a, let's do a -2 actually. Did I do? Yeah, let's do a -2. What if I did a horizontal as well as a vertical shift? Well, again, identify the vertex. Now, this is already in vertex form, right? We just don't have an A. You could say A is equal to 1, but we have an H and we have a K. That's a really bad H. So there's my H and there's my K. So my vertex, and sometimes like, I don't know, this sometimes gets confusing for students. I always like to do this sometimes, like, so we can see it. But see how it's x minus h, so h is equal to 2? I really want you to understand that, because when I write the vertex, a lot of students sometimes will get confused and like, why is it a 2? It's a -2. No. It's x minus h. So it says 2, comma, -2. My k is negative. My h is actually positive. So what this is telling me now is my graph, right? There's no stretching or compression. But what's happening is my graph is being shifted 2 units to the right and then now down 2 units. There's going to be my vertex right there, right? And then I can go over 1, up 1 for both of those. That looks like that. And that's going to go something just like that, right? Not going to be perfectly correct in here. And then let's just add one more transformation here. What if I put like a negative on there? And let's just say I did a x plus 2 and then squared and then a plus 1. Okay, well, hopefully you recognize if I'm minusing 2, if it's x minus 2, that's shifting it to the right 2. So if I'm plus 2, that's going to be to the left 2, right? And then remember, up 1 is going to be shifting the graph up 1. And then also don't forget that we have this negative, okay? So the vertex is going to be a -2, 1, right? And then all I really like to do is just make sure you find the vertex, like go and find the vertex, plot the vertex. So that's going to be at a -2, up 1. And then rather than going opening up, I know that it's negative, so I know it's going to be opening down. So I'm just going to go left 1 and left right, and then boom, graph it down that way. So there you go, ladies and gentlemen. Hopefully this video was helpful for you. If so, I look forward to seeing you in the next video. Cheers.